Alright, hey, what's up? This is going to be episode 10 on our video series journey of going from a noob to a veteran ASM coder. So in today's episode, we are in the final thread of beginner level, basic debugging and analysis of ASM codes. I think I forgot to mention in my previous episode, I switched the order up a little bit of a few threads right around this area, but we weren't at these threads during the time of the earlier videos, so the earlier videos like episodes 1, 2, 3, 4, etc. wouldn't be affected, but I just switched these up a little bit to make the order a little bit more proper. Okay, so yeah, we're on the final thread of beginner level, basic debugging and analysis of ASM codes. Extremely important thread, one of the most important. During your ASM journey, you're going to hit a lot of brick walls, if you will. There's going to be a lot of times where you'll learn a lot of information and then out of nowhere you'll get stuck for a very long period of time, and then you'll get like a light bulb moment in your head and you kind of sort of jump up to the next skill level. So you make these little jumps here and there with pauses in between. It's not like a steady progression. So to make yourself progress more rapidly or have more of these steps in progression, if you will, this thread is very crucial, because one of the best ways you can learn or to improve your own skill level is to take someone else's work or someone else's code that's a little beyond your current skill level and analyze it on Dolphin, debug it, see how they made the code, see why did they include certain instructions, or how did they optimize a listing of certain instructions to help you understand ASM more. Very important. Alright, so basic debugging. Alright, so first off, we're going to have to launch Dolphin. Just go ahead and launch everything. Launch your Dolphin, make sure it's in debug mode. Let me get the Dolphin memory engine up. Alright, we'll just run the American game, but before we do, we're gonna, now in this thread I use example of the classic shared item code, but obviously at this point in your ASM journey you really already know how these simple codes work, just load a value into a register and store it to memory. We're going to work with something a little bit less basic. This is positional shared item. It's a modified version, if you will. The original shared item is made by Star. It simply checks your position in race, and if the position value is what's supposed to, if it matches what the code is set to, then it will allow you to execute the shared item code. We don't need to worry about the activators and deactivators for this. We just need the base ASM code. So let me copy paste it and put it in a text editor for you to see. Let me open that up. Don't worry about this. Control plus. Okay. And paste that. So the P and the positional shared item code is position. Anything from 1 through 12, 1 through C. And WW is just the item. We can just do, I don't know, 3, I guess, just for that. So we'll put position. We'll leave it to position 1 and whatnot, and then we'll use item 3. So obviously when you're going to apply a cheat code in Dolphin, as usual, whatever placeholders you have for values that you need to fill in for the code, you're going to need to put them in. So we're just going to put 103, follow the instructions that the code requires us to run, copy it, put this back down. We're going to apply our cheat codes. No DC, we don't really need these two, but it doesn't really matter. POS shared item, got it added. Let me make sure this is America, NTSCU, ARMCE. That is correct. We are check marked. We are good to go. We'll launch the emulation. Give it a sec. Hook Dolphin memory engine up. Launch it. Close this file manager. Okay, so I think it was episode 6 or 7 or whatever it was. I can't remember. But remember I told you guys. Remember I told you guys about the two types of breakpoints. You'll have instruction breakpoint right here in memory. I told you a long time ago in the earlier episodes, like episode 2, we talked about different memories, static and dynamic. In the previous episode, we used values in dynamic memory to set breakpoints so we can find the static address and instruction responsible for affecting said portion of dynamic memory. So obviously, instruction breakpoint is going to be for static memory. Memory breakpoint is going to be for dynamic memory. I told you if you ever want to work on a code again, or work on a code that you already created or something, or if you found a default instruction that you want to save for later, you don't need to find the whole deal in dynamic memory again. You don't need to repeat the whole process. What you can do is just take the code's static memory address and set an instruction breakpoint. So we're going to do that. Just copy paste this part. So obviously it's mem80 and set. One thing to note about the shared item code address, that it only executes when an item box is picked up. Obviously some addresses will execute every frame, some addresses may only execute in race. It all depends, right? For shared item code, this also applies to the CPU. So if a CPU grabs a box, it's going to execute too, so keep that in mind. Alright, so we got everything good to go. Resume our emulation. Let's just get an offline race going. Now I have the positional shared item code set to where it would only execute when we're in first place, and it will give us a fib. Let's see. We'll use him. See if I get in first place. If not, it's whatever. Because remember, this executes for the CPU as well, not just when myself hits the box. See if we can get in first place. Beast mode. Alright, here we go. And as you can see, the emulation paused itself because the breakpoint was hit. Okay, so obviously, as I mentioned before, when you get a breakpoint that gets hit, you want to go to the code view. And as you can see, you're going to notice off the bat that something's a little odd. Now, here's the thing with insert ASM codes. They don't actually insert themselves in between two instructions in memory. That's literally impossible to do. So I don't really like how Gecko documentation calls the C2 type ASM codes insert ASM, because they're not really inserting. What the code handler does is it creates a branch, an unconditional jump. We talked about that instruction before, and it jumps it to a portion in memory that that's only used by the code handler, where the instructions of the ASM code is at, and then it'll branch back. So essentially what this is going to do, it's going to branch to that specific spot designated by the code handler. It's going to execute those instructions, and when it comes back, it's going to hit this load immediate shift instruction right underneath and just continue as if everything was normal. Some things I should probably mention off the bat before we begin is that you want to set up hotkeys. Very important, because a lot of times you don't want to use the mouse and move around your cursor to do certain things. To set up hotkeys, it's really easy. You have options, hotkey settings, and this is the toggle pause. I have mine set to 9, so this is the value you would set on your keyboard to pause and unpause the emulation. So these are all, it's really self-explanatory how to edit these. Just obviously right click for more options, middle click for clear, double click it, edit it, apply the value, click OK. So what you want to do is you want to do this toggle pause hotkey, and do this before you start debugging, by the way. So I apologize if I'm a little bit out of order. So toggle pause, and the next one you want to get is the most important one. You're going to use this a lot in your debugging and analysis. is step into. I have that set to the M button on my keyboard. Now what does step mean? Step means you're going to execute the code view one instruction at a time, and all rules are followed. So if a branch instruction was to be executed, you follow the branch. You don't just go top to bottom strictly no matter what. So if there's like a conditional branch and the conditional branch is met, you would follow it. Essentially, you're just emulating the CPU as if it was executing, but one instruction at a time. So when a coder talks to you and says, hey, you might want to step by step the code, or step the code, or that's what they mean. They mean get it paused via breakpoint, get the code view, and just execute it one instruction at a time. So you could find there's an error in the code, or why is the code freezing, or why is it crashing. Okay, so going back, we can see that the default instruction here at the address is replaced with this branch. So I like to have my multiple panels all viewed at the same time. I don't think I really need the Dolphin memory viewer for this, but it's always good to have. So I'm going to click back on my little emulation window, and we're going to click the M button, so how I set up. So over hotkey you have set up for the step into. What you're going to do is just click it once. Some things to note: these other values aren't really instructions. Like, these are just other compiled parts of the compiled ASM code right above, but sometimes they may get read as instructions just for the viewing of the code view. These instructions won't actually be executed in memory or anything like that. So as you can see, compare 25 to 1. So we know by just simply debugging this and stepping just one instruction into the code, we know that every time the shared item address gets called on, it holds the position value for whatever player it is at the time. So obviously I was in first place. I hit the box before any other CPU. It gets executed first, so we know all these values in the register are for us, or for ourselves, just us. And we see R25 is 1. So if we were to pretend that I was second place in some other I was second place and the computer hit the box, it would break for the computer first, but let's say we continue the emulation after the first breakpoint, let it continue, and then I hit the box in second place, this R25 value would be 2. Okay, so we now know that in the shared item code, when the address gets called, R25 is the position value of whatever player it is at that time when the box is being hit. So we have a simple compare R25 to 1. We're going to step that once. And one thing you notice off the bat as you pay attention, you see this CR. This is the condition register that holds various values, that whether or not conditional branches will be taken. So what the compare word and compare word immediate instructions do is they alter the condition register accordingly so the branches will be taken properly, whether or not the conditions are met. So we don't need to go in depth about this CR, this condition register, but just know when you see that change, that's the purpose. The compare will modify the CR accordingly, and then you have the branch instruction afterwards, the conditional branch instruction afterwards. So it says BNE the 251C, 8025.1c, meaning it'll skip if it's not equal, if our value is not equal to 1, we'll skip down, skip the load immediate instruction, and execute the store word, which we know is the default instruction of the shared item code address. Meaning, since the load immediate wasn't executed, the code is not executed, as if the code was turned off essentially. However, R25 is 1, so this conditional branch will not be taken. Another thing to note, we see the plus symbol next to BNE. Obviously, there's 12 different positions that you can be in the game at most. 1 out of 12 is unlikely, so it's always more likely that it's not going to be equal to your desired position. Hence why we have the plus symbol next to this BNE, because that conditional branch is more likely to be taken than not. But when you're a beginner coder and you're making these codes, you don't need these branch hints. I mean, honestly, even for advanced codes, you don't need them. It's just they've been used by a lot of coders over time, so it's just kind of a habit. So we know this conditional branch will not be taken because R25 is equal to 1. So we're going to head and when we do step, it's just going to go down. Now if R25 was like 2 or 4, if we would execute that step, we would be at the store word instruction instead. So we're going to load immediate 3. Okay. Now we're going to execute the default instruction. And we'll step that really quick. It just stores it to memory. We don't need to view it in Dolphin memory, but we know that's the default instruction. We know a value is getting stored to dynamic memory. As you can see, R23, if you add the offset value for the effective address, it's obviously a dynamic memory address spot. The NOP, obviously auto-added by the compiler, required for the Gecko code handler. If your ASM source has an even amount of instructions, has to be an odd amount. As you can see, NOP affects no registers whatsoever. And remember I told you about in ASM codes, they all have a finalized word of all null, compiled word of null. This tells the Gecko code handler that a branch back route, a branch returning where you left off from, has to be implemented. This is all done automatically by the code handler. It'll do it self-calculated, do it all for you. So we just step back one. Oh, and this is just, once again, this right here, not an actual instruction, just part of like the compiled. For the code handler, this is essentially a F0 line at the end that it's applied in the cheat manager for Dolphin. So the code handler knows it's the end of all the codes. So this instruction is not a real instruction. It'll never be executed. So anyway, going back to what we're talking about, do the step into feature one more time with your hotkey, and we're back to where we left off. And now the game can execute normally. So if I was to leave this breakpoint on and I unpause the game with my other hotkey, this would actually break again once second place CPU hits their box. And what would happen is we'll have some different values in the registers, and R25 is going to be 2. But that's if second place hits a box. Let's see whether or not second place does. We're going to unpause the emulation and let the code break again. Okay, here we go. Perfect. Now, another thing I like to mention, when you load up Dolphin and you get a breakpoint, the first time booting Dolphin in a session, any values in the registers that aren't 0 will be red. That's just standard. That's just how the registers operate on a first breakpoint hit. But if you're working on a breakpoint and you let it break again after resuming, if any registers change since the last time in a comparison to their previous values, they all become red. Notice these registers are all red. That means all these have been changed since the last time our breakpoint was hit, or the last time reviewing the registers when the breakpoint is hit. This doesn't mean that R20 stayed 0 the entire time. It just means if we viewed it from this time to last time, in those 2 instances of time, R20 has not changed. Once again, it doesn't mean that R20 stayed 0 the entire time. It just means for each particular moment in time. Okay, so here we go. Check it out. R25 is 2. So we know that this is the breakpoint for the second position place CPU when they hit the box. So we now know this. So now we're step by step in for second place CPU. Now check this out. We do the comparison. Notice how the CR on the right, the condition register, gets modified accordingly. The conditional branch value will be taken because it's not equal to R25 is not equal to 1. We skip the load immediate, do the default instruction, hit the NOP, branch back. And remember I had the value of 3? Well, we're going to get the item value of 3 for us in our item box from the first breakpoint we're talking about, because our load immediate 3. So one thing I forgot to mention is, notice how I did this. You can click to a left of an address and to toggle on and off breakpoints instead of bringing up the breakpoint tab or the panel and doing it that way. Obviously, this is only useful for static memory instruction breakpoints. You can also right click. You have all these other functions and selections you can do. You can copy the address. You can insert a NOP, so you can replace the instruction with a NOP easily. If you do replace the instruction with a NOP or anything like that, this down here, it's not highlighted, but it'll have a restore option, so you can restore the original instruction. And this replace instruction is you put in a compiled instruction, like anything. You put like any store word, any branch, compare, add, doesn't matter. I recommend having the Python compiler in raw ASM mode, Just put whatever instruction you want, custom instruction you want to do, compile it, take the compiled form, put it in this field, click OK, and you're good to go. So just a little FYI tips right there. We don't want this breakpoint anymore because I want to show you we're going to get our item value 3 in first place from the emulation. As you can see, we're not breaking anymore, and as you can see, I got item value 3, which stands for fib, and we'll just pause it and let it be. And I'll double check the thread, make sure we're not forgetting anything. More tips, went over that. So that's basically it, guys. That's what insert ASM code actually is. It does not insert itself in between two instructions. That's impossible. The code handler will have specified area of memory very early in Mem80 designated for your codes. It will create subroutines for your ASM codes to execute. They'll branch that spot in memory, execute the source instructions, then branch back where they and left off from where they, or just continue from where they left off. And that's basically about it, guys. Alright, that was the episode 10. Next episode will be episode 11, the first episode for our intermediate level threads, ASM tips and tricks. You're getting to the point now where you might actually have to worry about optimizing your codes as your skill level has been increasing ever so slightly, making less basic ASM codes. Alright guys, thanks for watching.